Let's talk about finding the domain and range of an equation from a graph. Now we're going to use interval notation for the domain and range in these examples. Little reminder, up in this box in the top right hand corner, we have what to do when our value is included in the domain and the range. So a filled in dot or a coloured in dot indicates that the value is included in the domain or range, and we use a square bracket for that value if it's the minimum or the maximum. If a value is not included in the domain or range, that is indicated by an empty or hollow dot. And we use a round bracket to indicate that that value is not in the domain or range when we write our interval notation. When we see an arrow on the end of a graph, that tells us that those values continue increasing or decreasing towards infinity. So we're going to use the square and the round brackets for writing our domain and range. So having a look at the first graph, I can see the minimum and maximum values for the x and y values. So let's start with domain. We know the domain represents our x coordinates. So the smallest possible value in our domain is the leftmost point in the x coordinate. So for me, that it's minus 1 to minus 3. So minimum possible value is minus 3. The hollow dot tells me that that value is not included in my domain. So I use a round bracket to indicate that that's not included in the domain. The maximum x value, so the furthest right point is this point here. That has an x coordinate of 1, 2, 3, 4. So the maximum value for my domain is 4. Because once again that is an empty circle or an empty dot, that value is not included in my domain. So I can go really, really close to 4, 3.9999999, but 4 is not included in the domain. So we use a round bracket to indicate we're going really close to 4, but we're not including it in our domain. Then we have a look at the range. So the range is the y coordinates, or the possible y values for our function. The minimum y value is the very bottom point. It's not the leftmost point, it's the very bottom point, which is at our origin, 0, 0. So the minimum possible value for my range is 0. Now because that's a filled in or a coloured in dot, we're using a square bracket to indicate you can have a 0 value in your range. It is included. The maximum possible value is at both of my endpoints, and that's 1, 2, 3, 4, 5. They both have a maximum y value, the endpoints of 5. Now, because that's that empty dot, 5 is not included in our range. We get really, really close to 5, but we never actually make it to the point 5. So the maximum value in our range would be 4.999999999 forever and ever and ever, but 5 is not included in the range, so we use a round bracket to indicate that. Looking at the second graph, the domain. This is once again our x coordinates. I can see the minimum x coordinate from left to right. The leftmost point is 0. That's at my origin. So the leftmost coordinate is 0. Because there's no empty dot there, we are going to include 0 in our domain. The maximum possible value. Well, it goes to the very edge of my graph, but then I can see these arrows on the end. And the arrows show me that that graph continues going on and on and on and on up to infinity in terms of the x coordinates. So our maximum possible value will be positive infinity. Now, because it is impossible for us to actually reach infinity, there's always a bigger number. We do use a round bracket when we're talking about infinity. Then we have a look at our range, our y values. The maximum y value that we can see on this graph is at about 3. And the minimum y value is about minus 3. But those arrows, once again, indicate that we continue going on and on and on and on and on. So that will actually take values from minus infinity all the way down at minus infinity up to positive infinity. Might take a while to get there because it's quite a stretched out graph, but eventually we can take y values from minus infinity up to positive infinity. Our third graph down on the bottom line. Now this whole graph is in the bottom half of the 4 quadrant axes that we can see here. The domain is once again our minimum possible x value. The minimum x value I can see on the graph is about minus 3. It's got that arrow on the end which tells me that it keeps going and going and going to infinity. So the minimum possible value is minus infinity. Once again, we use that round bracket because we can never actually make it to minus infinity. There's always something smaller. And we can take values up to positive infinity. The brackets tell us we're going infinity to infinity. Then we have a look at our range, our y values. The maximum y value I can see is actually the origin there. That's the very biggest y value, or the biggest range value, and that's at 0. So because that value is included, it doesn't have a hollow dot there. We use our square bracket to indicate 0 is included in our range. Oh, sorry, that's our maximum value. We always need to start at the minimum value. The minimum value for our range, you can see it goes all the way to the bottom of the graph, with those arrows on the end, so it keeps going. So our minimum is actually minus infinity again. Oops, and then our maximum is 0, and that is included. So from the lowest point up to the highest point. Our next graph, the domain, is our x values again. So we start with the leftmost point, and that's -1, -2, -3, -4, -5, -6. It has a coloured in or a filled in dot, which we can see there, so that we use a square bracket for our minimum domain value. And then we look for the maximum domain value, which is the furthest rightmost point. 1, 2, 3, 4, 5, 6, +6. And once again, that's coloured in, so we use a square bracket for our domain. The range, we look at our minimum value, which is not at either of the endpoints, but we can see the minimum value is at 0. Once again, that's a coloured in dot, so we use our square bracket. It is included in our range. And our maximum y value for the maximum value of the range is 1, 2, 3, 4, 5, 6. Which once again, it's not at either of our endpoints, but it's still the maximum value that graph reaches. 6, and because it's a coloured in dot, filled in dot, it's included, and so we use a square bracket. Our very final graph, the domain, the x values, I can see an arrow at the leftmost point on my graph and on the rightmost point of my graph. So that tells me that the domain, the x values, are from -infinity up to infinity. And in terms of the range, my minimum point once again has an arrow and the maximum point has an arrow. So the range for our very final graph is also -infinity to infinity for the range as well. Using those round brackets, because although we can get close to infinity, we can never actually reach it because there's always a bigger value, a larger value for infinity. So that's how we find our domain and range from the graph in interval notation.